This is the scan copy of the book in the field of the speech and language processing. The book is written by the author is Jurovsky. Actually, I have scanned these 2-3 pages to tell you that how important the Bayes theorem is. Actually, whenever you are working on the natural language processing, you know that in the natural language it is full of the ambiguity. So any persons, not only from the computer persons are performing doing the research in the natural language. You can also any electronics person can also do the research in the natural language processing. Okay, like speech recognition. You are going to receive the speech, and you need to recognize what are the words which are spoken. So in one side there is a speaker, and other side there is a receiver. So receiver is going to receive the signals. So this is the case of the speech recognition, and this receive once you go for the speech recognition, this is the field where even computer scientist can also work, and your electronics person can also work. Mathematician is also required in this case, because everything is probabilistic, and the mathematician is highly needed here. Mathematics is highly needed. So actually speech signals can be you have once you are going to speak, then you have some speech signals. So signals you have to convert into the Fourier transform, and whatever you can say, electronics persons can do more. So once you have the speech signals, you can convert to the Fourier transform, and then you are try to receive what was the spoken. So you know that we have the concept of the noisy channel, means you are sending the information, and due to the medium, actually your information is destroyed, and receiver is not going to get the proper information. So if you are speaking like I have a problem, so if you are saying that I have a problem, so I at the receiver end, what should be the I? It can be EYE, or it can simply capital I. So we have the ambiguity in every cases. So this is one field where you have to predict the you given based on the information. You have to, out of the number of possible possibilities, you have to predict the most probable word. So whenever you are going to predict the most probable word, then you can go for the statistics and Bayesian inference. Sometimes you are going to speak. Whenever you are going to speak and you have some speech signal, so the way you are going to speak means this is the pronunciation, how you can speak the particular word. So like the, how you can speak the the, and how you can speak the neat neat, or how you can speak the nedd need. So once you speak actually, then you have the phonemes actually. Once you are going to speak, then you have the phonemes. So your complete pronunciation is based on the phonemes you are going to speak. So sometimes we have two different phonemes. Phonemes means some tones you can say. So sometimes there are some persons from the Indian persons are going to speak differently, and the American persons are their phones are differently. So you need to identify that what is the correct word. What is the correct word? What is the most probable correct word given the observation? And observation is what? Observation is the sequence of the phonemes. So like you have the cases of just like you have the phones like n I ni. So this is the sequence of observation. Why it is the sequence? Because this is in the observation we consider the two things, one is n, one is I. So you have this is the sequence. So if you are given this observation, this need, like you are going to speak the need and NEED, or NEAT need, or NIL nil, or THE the. Some says that the or the. So you in phonemes this will also comes. So this is the observed sequence. So once you are given this observed sequence, then actually you need to predict. And we are interested for this argmax. This means O is means O means observation, and in this case it is given ni. This is the phoneme for some particular word. What we are going to determine the probability of the most probable word. Whatever words are there in the corpus, we denote the set of all possible words in the corpus. Corpus means set of words. Bank, actually this is the bank where and this contains the all possible words. So in that corpus you have the word, and for every word in the corpus you are supposed to determine the probability of the word. For every word you are going to determine the probability, what is the probability of this word given this observation. If the people are speaking like this, what is the probability that this is the word w, and whatever the number of words are there in your corpus, for every word you have to determine the probability, and the maximum, the words which gives the maximum probability, your system will give the output. Okay, this is the most probable word corresponds to the observation sequence. This is the you are going to determine, but it is very difficult to determine the probability of the words given the observation. So you can go the Bayesian inference, and you can use now the Bayes rules to transform this. So how you can how you can compute this? This can be computed in some different way, like probability of W given O, instead of words given O, you can, if it is easy to compute that probability for the word given O, but observation given the word, here the word given observation, or if you have the probability, if you come to know the probability for the observation given word, then you can use the Bayes theorem, and you know the Bayes theorem. This is the probability of xy. It means this is equal to probability of y given x times px, probability of x given and divided by the marginal probability. This is the marginal probability. So okay, so actually you are going. So this argmax probability for the, we are interested for determining the probability for the words given the observation. This can be applying the Bayes rules. You can convert to this. Earlier we are interested to determine the, what we are interested to determine the most probable word given the observation. Now using the Bayes theorem, you have represented this probability of W given O is like this. Probability of W given O can be written as probability of observed sequence given the word. Now you are need to determine that what is the observed sequence corresponds to the given word. So corresponds to the given all possible words in the corpus. For every possible words, you are going to determine the what is the probability for the observed sequence. Here you have the ni. For example, ni was the observed sequence, and for every words in the corpus, you are supposed to determine which word, what is the probability that this observed sequence is this, what is the probability that the word is W, and we need to know the observed sequence. So for every words in the corpus, you have some probability of the observed sequence. And if you can know, simply you don't require to know in details. If you are interested in research in this kind of uh, situation where you are supposed to determine the uh, you are dealing with the pronunciation, or you are dealing with the speech recognition, then you have to know. The question is that one, if you are not able to compute directly probability of W given O, you can use the Bayes. This is the Bayesian method, and you can use the Bayes rules for getting the probability of this. Now, probability of the observed sequence. So probability of the observed sequence, if it is difficult, since you are interested for the highest probable, most probable word, and this is the denominator. In the denominator, this is the probability of observed sequence. If you don't know the probability, then you can also omit this. Why it is so? Because maximum case is not affected. This is the case of the maximization. So maximization is not going to affect. So that's why you can also omit, and you just need to compute this and this. And this is the use of your Bayes theorem. So here you have the key concept is you want to determine probability of the O, probability of the observed sequence given the word W. So you have the probability, and this is the prior probability, you know that, and this is the likelihood. And what is the posterior probability? Posterior probability is this. Actually, this is the posterior probability we need to determine. We are based on this observation, you need to determine the posterior probability. So this is the question. So this is one case where you can apply. And also, if you have the error correction like AC or E double S, so you want to correct this. So there may be the typing mistakes, there may be some insertion or deletion of the letters like AC R double AC or E double S. Now T might be deleted. So here AC, after the C you should have the T. So T is deleted here. So is you are correcting. This is the error, and correction is this. AC R E double S, C R E double S, C R E double S. A might be inserted. CRE, someone might be interested for CRE double S, and A might be inserted. And these are the all possible correction. For the given word ACR E double S, these are all possible correction. And you may be interested to know that what is the what is the probability for the T. You may be interested to determine what is the probability. What is your interest? Your interest is to determine the C is the candidate of correction. Your interest is to determine the probability for C given T. What and for getting the same information, you have computed this. So T denotes the represent the typo, misspelled word. So misspelled word, and C is the candidate for the correction. So like ACRE double S, this is one of the misspelled word, and C is the correction. So if you are given the correction, what is the probability that this is the misspelled word, given that the possible candidate word is this? So you can determine this. Then probability for the C, possible candidate correction. These are the correction. So how you can determine the probability for the actress? So actually, for determining the probability for the actress is you need to access the corpus. So you are given the corpus, and corpus may have the, say for example, it may has the, this corpus may have, say, 40 million words. If it has the 40 million words, and out of the 40 million words, and you have the actress is one of the words, so how many times that, what is the frequency of this actress in the 40 million words? On the basis of that you can compute the probability. So 40, say if you have the 500, frequency of the actress is 500 out of the 40 million. So 500 divided by the 40 million, this is the probability for the actress. So this is the probability for the C, you can compute this easily, and probability this can also be computed with some other information. So computing the C given T, instead of computing C given T, you can compute the product of this, and you are getting the same answer. And this is the application of Bayes theorem in the correcting the words. Once you're typing and you have the typing mistakes, so what is the correct, most probable word, most corrected word? What is the correction? You need to determine. So this is also one way application. This is the, okay, these are the details how you are going to compute the probability and frequency. You are going to say frequency you are going to count, and you have the like this. So this is actually, I wanted to tell you that application of the Bayes theorem. So application of Bayes theorem is not only in the field of determining this, in the field of the mathematics. It is highly useful in the data science. It is highly useful in the natural language processing. Means it is highly useful in the within the artificial intelligence. It is also useful in the case of the finding the accuracy you are in your systems. Means some devices you are going to form, and what is the accuracy of that devices. The CPU chips are formed, what is the accuracy of that one? So yes, in everywhere. So in the robotics also you can use the Bayes theorem. So Bayes theorem depends on your research work. Whenever you are going to deal with the probability and Bayesian inference, you have to go for the, you have to apply the Bayes theorem. So speech recognition, I have already told you that. So if in the speech recognition, how you can apply? So you are in the speech recognition, you are given a speech signals. So you have given the speech signals. The first step of this is work is actually the segmentation, means you have to determine the word boundary. So word boundary means you have written, like say you have written max. So if in the, how your computer will come to know that it is max is written, it is going to see the big picture. So how your computer is coming to know that this is the written in the max? Like if you are driving a car and you are driving a car, okay, and and this is the car you are going to drive. You have some sort of situation like this. You are driving a car, okay, and you are sitting here, you can see, and you are going this way. You are driving a car and your eye is capturing the image, and this is the image captured by your eye. This is the image. So now on the image, how you are going to recognize that, how you are going to recognize the boundary of this road. Okay, this is the corner and this is the edges of this road. How you can recognize? How you recognize that, okay, these are the trees outside of the road? How you can recognize that, okay, this is some kind of animal is standing here like this? How you come to know? How you come to know that, okay, some person is standing on the road? So you are receiving as the image. The whole thing is the image. You are having the image, and on the image you are going to detect the particular object. And say your image, you have find some particular board, and in the board it is written that, okay, 500 kilometer, say some Delhi, say 50 kilometer next. So reaching to the Delhi is the 60 kilometer, 50 kilometer you are driving, and see your eye is going to receive this complete image, and out of these image you are detecting the object. You are going to perform the task of object detection. So you are going to say that object detection, and you know that this is one of the most promising research area, detection, because the result of this research is directly useful in the driverless cars and robot learning. So object detection is one thing, and so once your eye is going to detect this, now you have Delhi. How you would come to know that Delhi is written? So there are the method which you can form the one letter by letter. This is the boundary for one letter, this is boundary for other, and this. In this way you come to know that DELHI, this is the Delhi. So like this is the word. So you have the boundary. So if you are going to speech recognition, then you have some particular word. So this is one word, this is other word. So you have the word boundary. You can isolate the words. So this is one task. If you do, then next word is recognition. So based on the what you are interested for the particular word give, given the speech signal. So you need to determine the what is the most probable word based on this speech signal. So you may have the number of words, number of possibilities. Out of such possibilities, which word is having the maximum probability? And in this way, you are going to maximize the probability. So you are going to compute this. So you are interested for computing the probability, most probable word given the speech signal. This is the speech signal, and sometimes this is the difficult. So you can use the Bayes theorem, and instead of determining the W given SS, you can determine now. You can determine now signals given SS. So what is the probability of the signals is what given that particular words. So if you can know this, and you can know the probability of words by counting the frequencies, you can know, and the total number of words in the corpus, how many times the particular words appears in the corpus. In this way you are getting the probability. You can get easily by some method you can also get this thing, and then you will be, then your Bayesian method can come to know that this is the most probable word which was spoken. So you might have not listened properly, then you can come to know that okay, this might be spoken. So everywhere once you go for this kind of prediction, actually you are going for the output is only product probability. It is not the 100%. You are not 100% sure, but your objective is to determine the most probable word. So objective is to determine the what is the word which has the most which is the most probable word, means which is close to 1. The word probability, if you need to determine the maximum probability, means which is close to 1, and that is your answer. So see, these are the applications of your Bayes theorems. And machine learning, it has the direct use because it is everywhere is the prediction, classification, clustering method, everywhere is the useful. So there are a number of methods for the optimization. Out of these methods, there are some methods which use the probability theory, like the your genetic algorithm is also using the probability theory. Okay, and for computing the probability for the crossover, for computing the probability for the mutation rate, and for getting the probability for the for the rotating the wheel so that you can get the population for the next generation, and you need to determine the probability so that how you need to know that how many out of the populations, number out of the number n population, how many solutions of that population particularly they can go for the crossover, and what is the probability of mutation. All such things you require. Or if you go for teaching learning based optimization, TLBO, then also you can go for the probability theory. So simulated aliasing also you can use the in the case of the simulated aliasing, you can also go for this. Particle swarm optimization, you can also go, if you are going applying the particle swarm optimization technique, then you can also use the probability theory. So everywhere you have to use the probability theory, and with the help of the conditional probability, you are also going to use the Bayes theorem. So this is the highly useful. So this is just actually just an introduction, but you have to elaborate a lot once you are going to do your research work. Okay, so okay, this is just one example actually. So like your probability of this, what is the probability of the signal given the particular words? So you can determine like this. So like tomato, see this is one tomato. How you can pronounce tomato? So this is tomato. Somebody may go for this. Somebody may say that tomato. So somebody may say that okay, I will go for the this particular path. So somebody is going to go for this particular path. Somebody is going to go for this. Somebody says that okay, tomato. Somebody says that tomato. So there are two different ways of pronunciation. So somebody, you may be interested to know that what is the probability of the SS given the word. So probability of SS given the word. SS signals means this is the phone. This is the phone. Actually, you are going to determine the phone. These are the phone. TOMAE. These are the phones. So this is the signals you are going to determine. So what is the this phone means this is the observed sequence. So you have the TOMAT. This is the observed sequence. So this is the observed sequence given the particular word. Particular word. So you are given the particular word tomato, and observed sequence is this. So what is the probability of the pronunciation signal? This corresponds to the word tomato. So so what is the probability of this? So you can multiply. See, everybody says that tomato. Okay. So this is probability 1, 1. But once you are at here, you here, then somebody may say tomato, somebody may say this. So once you follow this path, then you have the answer 1 into 1 into 0.73 into 1 into 1 into 1. This is probability. If you somebody goes this path, then 1 into 1 into 0.27 into 1 into this. So what is the most probable? Probability is that this path is the highest probability. So people will say that, okay, yes, the probability is this. This is the probability that, okay, this is the signal corresponds to the word this. So you are going to determine. So this is the just example how people are going to use the Bayes theorem for determining the pronunciation, correct pronunciation, how you can speak correctly, or how you can use the Bayes theorem for determining the spelling correction or speech recognition. Okay, like this. So then these are the various applications of your Bayes theorem.